Okay, here we will look at the 2017 paper 1 for maths grade 10. Okay, first question says, given that q is equal to b squared minus 4ac all square rooted, determine the value of q if a equals 2 and b equals minus 1 and c equals minus 4, and they're asking us to leave the answer in the simplest third form. Okay, so the way to do that is to just take this same equation that they gave us and substitute in the values that we have. So in place of b, we'll have minus 1 squared, minus 4, and then in place of a, we'll have 2, and in place of c, we'll have minus 4. Okay, and then we'll just plug that into the calculator. Okay, and that gives us root of 33. Okay, so that's the answer for that there. I'll put all the final answers in blue. Okay, next question is, state whether q is rational or irrational. Now remember, rational numbers are numbers that can be expressed in a fraction form, so in the form of a over b, whereas irrational numbers can't be expressed that way. There's no pattern. So if we take root of 33, 33 isn't a perfect square, so that means that we aren't going to get a rational number. So that means that q is irrational. Okay, between which two consecutive integers does q lie? So now you take root of 33, you put it into your calculator, and you see what the value is. So root of 33, if you put it into your calculator, you'll get 5.744, and then it goes on. Right, that's another way to see that this was irrational, because the calculator spat it out, and not in a fraction form. But anyway, so the two consecutive integers that it lies between is obviously 5 and 6. Okay. The next 1.2, factorize the following expressions fully. Okay, so let's see how we're going to do that there. Now, if we look at this here, it on the surface looks like we can't really factorize anything, but that's not true. Let's see how we can change things around to make it factorizable. So if I take this here, t squared r minus s, and I manipulate this in a specific way. So let's do this by taking out negative 1. Okay, let's multiply negative 1 by this here. So obviously we'll have r and minus s, right? Let's see if that makes sense. If we multiply minus 1 into there, I'll get minus r, and then if I multiply minus 1 by my minus s, I'll get plus s, and you can see that's the same as that. So that means that that's fine. Okay, so now that we have that written like that, you can see that we have a common factor. R minus s is common. So we can further factorize that now by taking out that r minus s. So we'll get that, and then t squared minus 1. Okay. Now if we look further though, if we look at t squared minus 1, we can still factorize that further, because remember, difference of two squares. T squared is a square, of course, and 1 is a perfect square as well, because 1 squared is 1. So I can write that as r minus s, and then t minus 1, t plus 1. Okay, because remember, for difference of two squares, let's say I have, for example, a squared minus b squared. That would become a plus b, a minus b. So you can see there we did the same thing with t minus 1. Okay, and then that's the final answer here. Okay, cool. The next question, 1.2.2. Let's bring it down here and look at it. So we have x cubed plus 1 over x squared minus x plus 1. Okay, now remember for cubes, if you're adding two cubes, so x cubed again is obviously a cube, and plus 1 is obviously a cube as well, because 1 cubed is 1. Okay, we can simplify that there. So we start off by taking the two things and adding them, so x plus 1, and you multiply that by x squared minus x plus 1. Okay, so the general form of that would be, let's say I have a cubed plus b cubed. It would be a plus b multiplied by a squared minus a minus ab plus b squared. Okay. Okay, so that's the general form of that, and then we applied it to this here. Now, if we take that there and divide it by our original x squared minus x plus 1, you can see now that we have some common things there, so we can cancel that out, right? And then we end up with x plus 1 as the final answer. Okay, let's look at question 1.3 now.